Hey, it's Max again. Continuing on from our last video of creating a UberJar or FatJar of our Java Spark web application, we're now going to try out deploying this to Amazon Web Services. The pattern for doing this is pretty similar if you aren't using Amazon Web Services, but I just figured I'd illustrate using a popular, albeit flawed, web hosting platform. So first things first is we've got our build Gradle, we've got our hello world. One of the things that I'm going to suggest we do in preparation for deploying to AWS Elastic Beanstalk is we're going to say the port that we're going to serve our app from is port 8080. So reason being is that there's some defaults to Elastic Beanstalk that I figure we'll just honor rather than trying to futz with. So let's just verify still that our FatJar serves at port 8080. We'll go to our browser, we'll go to 8080, we'll need to go to the URL hello. That still works. Let's also just add a couple of routes. So we'll have a index page, we'll just call it index, and we'll have a health URL, which just returns hello max. So that being said, let's do one more build of our jar because we're going to need to upload the jar to Elastic Beanstalk. A lot of this video is going to be compressed because a lot of time is spent waiting for Amazon Web Services and Elastic Beanstalk to provision resources. But first things first, if you haven't already, create an Amazon account, go to the AWS console and navigate to Elastic Beanstalk. There's a lot of Elastic named services that Amazon offers. We'll click create application. We're going to be creating our first application, so we'll call it Spark example. Now we're going to want to choose Java as the platform, and Corretto is a flavor of JDK that Amazon provides open source. We're going to just use that. It's a drop-in replacement for OpenJDK 1.8 or version 8. Now instead of clicking sample application, we're going to upload the jar that we have. It's a local file. If it exceeds 512 megabytes, which our Spark app will not because it's a very small web app, we could upload that jar to an S3 bucket and then specify the S3 bucket for Elastic Beanstalk to download the file from. But let's navigate to our project. Select the jar we want to upload. Click open. Now it'll take a moment to download, and while it's uploaded, it'll take a moment to upload. Let's click configure more options. And here's where we're going to do a little bit more interesting things. So first thing we're going to do is we're going to scroll to the top here, and instead of choosing the free tier eligible, we're going to click high availability. And what that does is you'll see there's this section called load balancer, and if we have single instance selected, there will be no load balancer. High availability does have a load balancer. It does auto provide you in what's called auto scaling group, and it has a maximum of 4 instances. And I had issues with the single instance deploy earlier, so we're going to stick with a load balancer in front of a single by default EC2 instance. If these words mean gobbledygook to you, it does to a lot of people, so don't sweat it. But the key of it is, let's get explicit and let's tell Elastic Beanstalk exactly the port number that our app is going to be listening to, as we added here. This is a method that if we go to Spark's docs, there's a section on its embedded server and how to specify the port number. By default, it's 4567. We've set it to 8080. And so having set the environment variable port equal to 8080, I think we also need to select a security group. I had issues previous when I did not choose one. Let's edit our load balancer and verify that. Let's use the classic load balancer. Anything else we need to do here? We can specify a health check URL. In our case, we made it /health. Let's bring down the interval to maybe its minimum. Let's hit save. This is all just configuration to try and make deploys happen faster, as we have a really small, minimal web app. A lot of these default settings are not appropriate or necessary. But I think we're all set. Let's click Create App, and bear with us because Amazon's about to provision a fair number of a variety of things. One is the physical computer or virtual slice of a physical computer that our app will be ran on. It needs to download the jar that we've uploaded. It needs to do a variety of bootstrapping operations in order to prepare that virtual machine on EC2 to run our jar. But bear with us. I'm going to pause here and wait for probably 5-10 minutes as Elastic Beanstalk does all of this provisioning. So while this is completing, let's take a look around at the dashboard for managing an Elastic Beanstalk app. First off is a configuration page where you can edit a lot of the settings that we were configuring before creating our app initially. So after you've created an app, if you need to change things, you can change things from this dashboard. We are not needing to change anything more. There's a variety of other items. For example, being able to download the log files that are accumulating on your application server for debugging reasons, for analytics reasons. By default, Amazon's logging is kind of not very useful. Ideally, this web interface would show us a real-time streaming log of, access requests of our web app, health events in the life cycle of our web app and web server, but Amazon's just not great at that. No offense, Amazon. Let's go and check out the Events tab. That's where we can monitor whether our application is undergoing a state change. By default, it has the most verbose severity for printing out events, which is ideal. In this case, it looks like it has completed successfully launching our environment. Looking in reverse chronological order of what happened, it created an EC2 instance and added it to our environment. And again, reverse chronological is that our app finished starting. Initialization completed 4 seconds ago and took 2 minutes. That can't possibly be the time it took to start up our jar and listen on port 8080. It was probably a bunch of Amazon bootstrapping stuff. So last but not least, we can click Go to Environment, which should take us to the URL of our Elastic Beanstalk's load balancer. Sweet. Looks like our application's being hosted from behind the load balancer. Let's check out our health check URL. Health. Cool. Looks like we have our app deployed. Next things I would suggest, now that we have our application up and running, is that instead of logging into this AWS console and having to upload and deploy a new jar every time from our local machine, that's something that we should definitely automate. That's something that can be done via another Amazon Web Service called Code Deploy. Another option is to stand up your own Jenkins instance and use Jenkins to kick off builds and upload our jar and perform an Elastic Beanstalk redeploy whenever we change our code. Another option is using another service such as Circle CI or Travis CI. I'm not sure if I'll make another video about how to do that. It's a little bit involved, but I think I'd rather show how to use alternatives to Elastic Beanstalk, if I'll be really truthful, just because I'm not a big fan of them. I think there are better options out there for hosting and ease of hosting, like Heroku. It took me probably an hour to make this video because of how kind of obscure some of the problems are that you encounter with creating an Elastic Beanstalk app. But otherwise, I hope this was helpful. I hope you guys can get through the details of using Amazon Web Services. If you got any questions, leave them in the comments. Like, subscribe. I'll be making more videos. Talk to you soon.